Hello chemistry. This is the video that goes along with lab 29, calorimetry. In this video, we're going to do 4 calorimetry experiments. 1, 2, 3, 4. I've set the calorimeters out already, as well as filled them with the appropriate amount of water. All right, so 170 milliliters for experiment 1 and 2, 100 milliliters for experiment 3, and 200 milliliters for experiment 4. You can see the mass of each object. I weighed them when they were dry. The nail that we're going to use weighed 6.82 grams. The glass cylinder weighed 6.53 grams, and the metal rod weighed 17.27 grams. Okay, so all that's really required for us is to come and take each of these objects and put them into the different calorimeters. We can measure the initial temperature of each of our calorimeters here. I'm going to do them all at once. You could just record this data. If you're doing this on your own, you would have to do each one individually, but I've set them all up here. So it's 22.3 and 22.1, I guess. This one over here is 20, 22, and this one here on the end, 22. All right, let's go back to this first one. All right. One reason why this one might be a little bit hotter is actually it's sitting close to this hot plate here, which is pretty hot. And so some of the air from the hot plate is actually probably making this cup a little hotter here, 22.3. Because we get colder as we go away from it. 22.3. This one's 22.1. This one's 22 on the nose, and this one's 22 on the nose. But those are pretty close to each other, okay? So we're going to take our first object here, which is our metal nail, and we're going to drop it into the calorimeter and watch the temperature increase. All right, we started at 22.3. Now we're up to 22.4, 22.5. And it looks to me like we're only going to get a very small temperature change here of about 22.3 to about 22.5, or about 0.2 degrees Celsius. Okay, 0.2 degrees Celsius there. All right. Imagine that each of these metal objects, before we transfer them, is about at 100 degrees Celsius because they've been sitting in our water bath for over an hour, actually. Okay, time for the glass. All right, here's our glass. We're going to drop it in here. It's starting at about 22.1. And 22.1 to 22.5. 22.6. So this one went from about 22.1 to about 22.7. So whereas this one went up about 0.2 degrees, this one here looks like it's going up about 0.5 or 0.6 degrees, okay? So those are the two values for these two ones here and here. All right. Now, the third calorimetry experiment that we're going to do here it is to identify the unknown metal cylinder here. The cylinder weighs 17.27 degrees. We're going to come up with the specific heat of the cylinder and hopefully identify what metal it is. Okay? So we're going to take this cylinder. It's been sitting here at 100 degrees Celsius for a while. We're going to drop it into 100 milliliters of water and see what happens with the temperature. Okay? Starting at 22. See what it does. We're going to swirl this water around to kind of make sure we get to a nice thermal equilibrium value. You want to wait till it stops going up. All right, so it started at 22 and went up to what looks like 24.4 degrees there. All right, so that one got a little warmer that time. We can actually turn our water bath off now. 24.4. We'll let that kind of sit there and see if we can see if it comes back down or if it goes up a little bit more while we set up the second part of our experiment, or sorry, not the second part, but the fourth calorimetry experiment, which is a little bit different than the other two. Okay, so we're going to just let experiment number 3 hang out there for a minute. Get cup 4 ready to go for experiment number 4. And so that one doesn't look like it's coming down really at all. It looks like it's staying at 24.4 degrees Celsius there. Okay, so all experiments 1 through 3 started, remember, at the same temperature, 100 degrees Celsius, but we got to different final equilibrium temperatures in each case. Make sure you have them all recorded, and you can go back in the video and rewind if you need to get those numbers again. Okay, but I think that is pretty much thermal equilibrium there at 24.4 degrees Celsius. Okay, we're going to come over and stick this into our 200 milliliters of water over here. We're going to let this come to room temperature. See what we get. While that's doing that, we are going to start our Bunsen burner. All right, make sure we got a nice flow of gas through there. And in this experiment, we're going to be heating the iron nail, the same one we used in experiment 1. We're going to be taking this iron nail, so it has the same mass here as it did originally, and we're going to heat it until it's glowing red hot. All right. Then the goal will be to drop it straight down into the cup and see the temperature change. All right. We're going to be trying to calculate the initial temperature of this nail when it's glowing red hot. Okay. So this is a really fun one to do. I'm sorry you guys have to watch this on video instead of being able to do it yourself, but hopefully you guys can see the metal start to glow here. This is a really fun one to do, so again, I'm really sorry you guys aren't getting to do this one on your own, but that's the way it goes. All right. So if you remember, the hottest part of the Bunsen burner flame is the inner blue cone. So right now I've got my nail in that inner blue cone. I'm heating it up. And you can see that there. Hopefully you can see it on the video that it is starting to glow red hot down there on the end. I'm going to see how much of this nail I can get to be glowing red hot. So one of the problems here in trying to get this nail perfectly hot or completely glowing is, remember, heat is constantly being released from the nail, so it's constantly cooling down, and it cools down faster the further it is away from the flame. And so really we can only get the part of the nail that's right in that inner blue cone to start glowing, all right? But we're going to just keep heating this. Try to get it as hot as we possibly can. And then we're going to drop it straight down into the water. You've got to be really careful when you drop this nail into the water so that you don't melt the styrofoam. Right. Once the nail goes into the water, it will cool rapidly. So you don't have to worry about it like poking a hole in the bottom of the calorimeter, but you don't want the hot top of the nail to press on the side, okay? And hopefully you can see that, right? It stops glowing almost as soon as I pull it out of the flame, but maybe you can see that it is very hot. The Bunsen burner flame is over 1,000 degrees, so you're gonna be calculating what you think the actual temperature of the Bunsen burner flame is. Alright, this nail is going pretty much red hot, almost all the way through now. So I'm going to go ahead and quickly drop it in. You could see the room temperature water here in the calorimeter number 4 is at 22.2 degrees Celsius for the initial temperature. Let's go ahead and drop it in real carefully here. I'm going to move the Bunsen burner flame over to the side. Alright, we're going to move the probe out to start. And then remember, we're going to drop it straight down into the water and hopefully we don't melt this out of the cup. We did not melt this out of the cup. Good. Alright, so let's watch and see what the temperature does here for the iron nail. Remember, when the iron nail was at 100 degrees, we saw a very small temperature change, right? We saw a temperature change of like 0.2 or 0.3 degrees. Now, we were at 22.3, I believe, was the initial temperature. And we're up to a final temperature here, quite a few degrees higher, of 25.8 degrees Celsius. Looks like about the final temperature here. We'll just let it sit for just a minute or two and make sure this is indeed our final temperature. Oh, 25.9, see we went up a little bit more. All right. We'll give this like a little swirl here and make sure this is the actual final temperature that we're going to get. 25.9. Alright guys, so that's the calorimetry lab right there. There are 4 labs to do. There are a good amount of analysis questions that ask you to compare our measured results here to what we would calculate with what we know about the different materials, as well as identifying the specific heat and the identity of this metal rod. And then the 4th experiment, you're going to be determining the initial temperature of the iron nail. It should be very high, right, because we had it glowing red hot. All right, good luck, and I'm here if you have questions.